In this practice, you'll be stripping insulation from wires. Several types of wire strippers and cutters are available. Be careful not to cut the strands of the copper wire. The wire which has been chosen to work with here has 30 individual strands, each strand being 0.038 square millimeters. Some cheaper tools may damage the individual strands of wire and must be avoided. Visually check the wire which has been stripped for any damage that may have happened to the individual strands. If damage is seen, strip a new fresh section of wire. Carefully note the natural lay of the strands of the wire and then slowly wrap them together to make a nice tight end to that wire. With a 30mm section of the copper wire exposed, bring the clean tip of the soldering iron to the wire and make a heat bridge with the standard 60/40 tin lead solder. Hold the soldering iron in one place and move the rosin cord solder to completely tin the wire strands, but do not let the solder wick underneath the insulation. Examine the soldered joint for any signs of defects. Defects include flux inclusions and areas of non-wet which still show the copper with no solder tinning. This is obviously a defective solder joint and it will have to be redone. The first step in the process is to start with a clean soldering iron tip. Then apply a small amount of solder to the tip. This is what we call tinning the tip. Take the tip to the wire, hold the tip in one place, make the heat bridge, which will allow a lot of heat to go into the wire, and then move the solder to completely tin the wire. The visual inspection here shows that there's no areas of non-wet and there's not too much solder at any point on the wire. It's a perfect tin connection. So that we've already done one very successful tinning of the wire with the solder. It's very important to understand that not all solders have the same characteristics. If you had chosen to use the multi-core Alusol, then things certainly wouldn't have gone quite so smoothly. In fact, if we examine the contents of the Alusol, it's designed for soldering to aluminium and aluminium alloys, stainless steel. It has approximately 18% tin, 80% lead, and about 2% silver. Although it can be used to solder copper wire, it requires a lot more heat and a lot more practice to use this type of solder. Be sure that you clean the solder to remove any grease and any impurities. We go ahead and we make the heat bridge. We can see a lot of white smoke from the rosin burning, but quite obviously The solder does not water flow. The soldering iron is running at approximately 320 degrees Celsius. Normally that amount of heat would be fine with 60-40 solder, but with this particular solder we're really starting to encounter some problems. Increase the heat on the soldering iron to more than 360 degrees Celsius and try again. Marginally better, but still really not what we would expect. Normally we would have a satisfactorily tinned copper wire, but we visually inspect this one and we find it has numerous problems. Now to twist two wires together and complete a soldered joint. It's a slow twist. We don't want any high spots or low spots in it, because usually after the soldered joint is completed we'll want to put some heat shrink tubing over the top of this to act as new insulation. As before, we'll start with a clean soldering iron tip, tin it with a bit of fresh solder, take it to the job, make a heat bridge, and basically keep it in one position while we move the solder to the various points on the wire that we're soldering. Don't worry if it seems to take too long to complete the soldering process. This is a very large joint with both pieces of copper wire wrapped one over each other. It needs a lot of heat and more time than would normally be required to do just tinning on one wire. The finished joint will be very hot. Never blow on it or attempt to cool it. Just let it cool by itself. Visual inspection shows a near perfect joint. All of the individual strands of the wire are still visible. There's not an excess of solder. There's no excessively high or low spots. The finished joint now is ready to have some heat shrink tubing placed over it if required.